Greetings, everyone. Welcome to the webinar on HPE Solutions for Oracle. A quick logistic check before we get into the webinar. A separate window will pop up for webinar presentation. If you have a question, please click on Question Manager icon at the top in My Room to type your questions. Click on Content Panel icon at the top in My Room to access handouts. The slides are made available as handouts. And please respond to survey when posed during the course of webinar. Today we have two eminent speakers, Kyle Todd and Mike Voica, who are helping us with the webinar. I will hand it over to Kyle to take it forward from here. Kyle, over to you.
Okay, great. Thanks very much. I'll go ahead and load my slides. So if you would tell me when you can all see them, that'll probably be the biggest technology challenge. All set?
Yes, all set.
Okay, terrific. If you're running HPE servers, there's a great chance you're running Oracle software. HPE servers is the largest installed base server platform for Oracle Solutions. We have 140,000 installations or customers running Oracle software on our servers. And we frequently hear the same two things over and over again from customers as we talk about what the challenges are that they're facing. And the first is obvious, it's cost. And there are a number of reasons for this. One is that since Oracle charges for their software on the basis of how many cores are running the environment, prices tend to go up over time because data keeps getting larger and the amount of time required or the amount of time demanded by users internally and externally of enterprises keeps going down. So something that used to run in 4 hours now needs to run in 10 minutes, or 10 minutes now has to run in real time. So the way that most folks deal with that is they increase the compute capability. Well, when you add servers and you add sockets, you drive up the cost of Oracle software. And the other cost is associated with the support agreement. Most Oracle customers have a 3-year support agreement, and 6 months before that 3-year support agreement expires, there's typically a review of the environment, and almost invariably, what's found is that the number of cores has gone up to keep pace with the compute requirements. And because of that, the price of software has gone up and the price for the next support agreement has gone up. So we frequently speak with customers that are nearing the end of a support agreement and they're concerned about what they can do to keep the cost down for the next 3-year increment. Or they've got a new project and they may not have the budget to spend on additional licenses. So what they're looking for a way to do is make their use of Oracle more efficient so that they can transfer those licenses to a new project instead of having to buy new licenses all over. And the reason that this is so critical is there's probably never been a time in our industry when IT innovation is more critical for every single company out there. No matter whether you rent cars for a living or sell books or sell groceries or monitor electricity, the amount of competition is incredible. And frequently, it's technology that provides that competitive edge. But the problem is that so much of your IT budget is pre-allocated to infrastructure support, like software and software license support. That's an issue because you can't fund the innovation that you need to stay competitive. The reason performance, I mentioned a bit ago, the reason performance is so critical is that data just keeps growing and growing, both structured and unstructured. So the other factor that's a big cause for concern is response times. So it used to be adequate to generate a report at the end of every 8-hour period, and then it became every hour. And what's frequently required now is real-time everything. And it's certainly what customers require. If you log on to a website and you see a spinning ball because the response isn't instantaneous, as a consumer, you get annoyed at the company. Well, that's a tough bar to rise to for every customer. And so storage and server performance is a critical element in customer loyalty. So the way that we can help is HPE has a staff of people with as much domain expertise around Oracle as we do around our own infrastructure products. So what we offer is a consultation with a subject matter expert who can sit down with you or Skype in via a phone call or a con call and talk about what your objectives and issues are. Some folks don't have an issue with performance, but they've got a huge cost concern. I speak with customers all the time who are just the opposite. They might have just signed a new 3-year support agreement with Oracle, so they may not be as concerned about license cost and expansion, but they just found out that they've got a huge new project that needs performance they've never tackled before. So these are the issues that we try to uncover in that introductory call. And then the next thing that we do is we do an assessment using something called the Database Performance Profiler. This is a tool that HPE owns, and we're able to make it available to our customers at no cost. And frequently, when I've surveyed people that do this for a living, it's not uncommon for an exercise like this to cost $25,000. So it's not an inexpensive protocol to implement, and the fact that we're able to offer that for free for customers is got a lot of value. What we do with the DPP assessment is we're looking for the performance bottlenecks that artificially inflate the cost of Oracle software. Because if we can figure out what is slowing down your Oracle environment and we can address that through infrastructure, it can potentially save an enormous amount of money from a license and a support cost standpoint. So the value of DPP is, unlike an AWR data, unlike AWR, we're looking at a broad expanse of time. So we can look at what CPU utilization looks like over the course of days and weeks, or even months. And we've had a number of customers that have business that's very seasonal. So they might want to look at a specific point in the calendar, 8 or 12 weeks, understand what the performance and the CPU utilization is over that period so that they can prepare for those busy periods. We can also look at I/O peaks and valleys, and we can determine whether their performance issues are caused by compute or whether they're caused by I/O. We have an enormous installed base of customers who use Oracle RAC, and sometimes they use it for real-time failover, but frequently they use it simply to scale large workloads. Well, a DPP assessment is able to determine whether RAC is providing value from a scale standpoint or whether potentially it's inflating the cost of the whole environment. But the bottom line, and the thing that's most useful, is rather than HPE coming in and recommending you buy this product or that product, we can determine for your specific Oracle implementation, what are the performance characteristics and requirements, so that when we recommend something, we know from empirical data for your specific workload that it's going to address the issues that you've got. So I mentioned AWR just a moment ago. That's the data that's automatically collected every 60 minutes with Oracle software. And that spreadsheet that you see on the top of the slide, that's what AWR looks like. What you see on the bottom is a DPP graph. And what DPP is able to do is take literally hundreds of those small spreadsheets and turn it into a trend line so that you can look at performance over long periods of time. You can look at peaks and valleys, and the different things that we're measuring are all color-coded so that there isn't a lot of confusion over what you're seeing. So rather than requiring an advanced degree and looking at AWR data, you can look at something that's just very, very intuitively obvious in terms of what performance characteristics we're seeing. And as I said a moment ago, you can look at long expanses of time. So we've had customers where we've done DPP assessments and they've had, say, Friday afternoons, just terrible performance. And we looked at all of the different workloads and we figured that they could solve their problems simply by reallocating the time over the course of the week at certain jobs. In other situations, we find out that it's performance tuning that they need. But in a lot of situations, it is actually infrastructure, which is the culprit. And if you address the infrastructure issues, you lower the cost of Oracle software and you improve the performance. I'm going to give you some examples. I mentioned RAC a moment ago. So RAC does two things. It's real-time failover. And if you're in a mission-critical environment where even 5 minutes of downtime every year would be unacceptable, and we can, with our servers, we can achieve 5 nines, which is only 5 minutes a year. But if 5 nines is not good enough and you need real-time failover, RAC does that quite well. But if you're looking to scale a workload, frequently there are alternatives to RAC that can provide equal or better value, and certainly from a monetary standpoint, equal or better value. So this is a real-life DPP assessment we did. It was a PeopleSoft environment. PeopleSoft is an environment that is difficult to scale well with RAC. And what we found is in a 3-node cluster, the slide on the left, that image shows the throughput for one of those 3 nodes. It was 18.16 gigabytes per second. What we looked at on the right was the combined performance of all 3 nodes, and it was 18.21. So in a situation like this, you're not getting a lot of scale capability from a clustered environment. So for this customer, it was much more preferential to run the entire workload on one slightly larger server instead of having the additional database and rack licenses and scaling it across 3 servers. And because DPP has the ability to produce insights like this, the customer was able to save a significant amount of money. In another workload environment, we found that you had a 64-core server, and the CPU utilization never went above 12%. And when you consider the cost per core for Oracle software, to be paying for cores, for dozens of cores that you're never using, is probably not the ideal way to spend your IT budget. So with this customer, we're able to put them on a much smaller server and to use VPARs and NPAR technology and even ICAP to reduce their Oracle costs. Because as you all know, in an HPUX environment, you can partition off the number of cores that are being used to run Oracle software, and you only have to pay for those cores that are in an active partition. We have a number of customers that are running Oracle software in HPUX environments, and they're looking at Exadata because they've read material that says Exadata is the ideal place, the optimal place to run Oracle workloads. Well, what DPP is able to do is analyze your specific workload and make a pre-qualifying determination whether Exadata would be well suited or not. So there are some OLAP environments where Exadata is expensive, but it's effective. And then there's OLTP or mixed workloads environments where Exadata doesn't always provide the value that you might be looking for. So with DPP, instead of just making a wholesale move and migrating everything to Exadata, you can analyze your workloads. And the tool is able to provide insights as to say whether this is a great environment for Exadata and it will be optimized, or whether this is an environment that even with all of the special sauce that Exadata has, your workload performance isn't actually going to do all that. So it's a great way to assess workloads when you're looking at migration options. The other issue is that what we frequently see is issues with I/O. So if you're an Oracle DBA and you see latency factors of 5 milliseconds, that's something that makes you a little nervous because that's a long time. Problem with long waits with I/O is that when the data finally is retrieved, you have to compensate for all that lost time by increasing the compute power. Well, you pay for compute power. You don't pay for storage, but you do pay for compute power. So if you're compensating for poorly performing I/O by adding more CPU cores, you just drove up the cost of your own software. So we see this all the time. And what you have on the left is a worst case scenario. There you've got latency factors of up to 60 milliseconds, which would make a DBA go screaming from the room. What you see on the right is milliseconds that are frequently 1, 2, 3 milliseconds. Very, very low. So in a scenario on the right, the storage is fine. I/O is fine. You can look for other areas to optimize, but we see a lot more of the slide on the left than we do on the right. So there's plenty of opportunities to reduce your Oracle license cost by reducing the number of cores through I/O improvements. So best example of what a DPP produces is we can look at optimizing your performance by looking at whether you've got compute issues or I/O issues. And we come out with a proposal that shows you how you can consolidate your workloads and reduce the number of cores. And the best part about it is it includes a highly detailed TCO and return on investment analysis. So you're not just blindly saying, let's upgrade all these servers or let's buy some new storage. We're able to tell you at a very detailed level what we estimate the cost savings will be going forward. And what you see on the screen now is a DPP assessment that we did for a customer. Their current state. So if you want to follow me through the slide, in the upper left-hand side, you see their current state with 10 servers. And they were deploying a huge Oracle e-business suite environment. And the recommendation was that they should have a total of 22 servers. Well, what we determined was that by going with a very different architecture and upgrading some of these very old servers, they could get away with far fewer servers, only 18. They didn't need 22. 18 was going to be fine. But the huge win is look at how significantly we were able to reduce the number of licenses. So the enterprise processor licenses, instead of going up to 82, we said you only have to go from 40 to 52. It's not a heavy lift. Look at the number of rack licenses, sort of to the right center of the screen. The proposal was to have 1,600 rack licenses. We were able to design an architecture that required only 300. That is, when you look at the list price of rack software per CPU core, that's a fortune. So we got information from the customer about what their Oracle discount was and plugged that in, or they gave us a ballpark and we used that, and then they could refine that as they wanted. And we looked at what their current state was, we looked at what was being proposed, and then we gave them the alternative. And with our proposal, we were able to save them $2.1 million on day one because they already owned a number of the licenses. They just needed to transfer them to these new systems. And in addition, there were a lot of licenses they didn't have to buy at all because we were going to have so fewer cores to support the same environment. So day one, they saved $2.1 million in avoiding Oracle license costs. And over a 3-year period, they saved $1.3 million in support costs. And the reason for that is the average support contract cost is around 22%. That's fairly common in the industry. So if you look at 22% of all the software you own, that can add up to a lot of money. So for this particular customer, saved $2.1 million in avoiding license new acquisition, saved $1.3 million in those support costs. So the total return on investment was $3.4 million in savings. A very, very significant win for the customer. And all because we did this DPP assessment. That's what gave us the kind of data that we needed to do this. So a couple of the FAQs that frequently come up, what are the guidelines for doing an assessment? What we're looking for is systems in a production environment with a minimum of 24 cores. Because the objective is to make sure that there's enough efficiency that we can obtain to make it worth your while. And even though it isn't a heavy lift on the part of the customer, we want to make sure that the environment meets a minimum level of size so that it's a worthwhile exercise. Second question that typically comes up, does the DPP tool run only on HPE servers? Absolutely not. In fact, the DPP tool itself runs on a laptop, and then it extracts AWR data from whatever servers are running Oracle. So we commonly see this with Integrity Itanium servers, where a customer is on Itanium i2, and they want to upgrade to the latest Itanium. They want to take advantage of the performance gains and but they want to make sure that they don't over-provision their environment. Because from a cost standpoint, you might overspend a little bit from a budget standpoint on hardware, because hardware is relatively inexpensive. But if you over-provision your servers from an Oracle cost standpoint, that's a huge issue. So it's very, very common for us when we're working with our UX customer that before we even put a recommendation down, we say, let's just do a DPP assessment. Let's look at the workload characteristics. And you might be able to move to smaller servers if you go with more powerful systems. You may be able to go to smaller servers because your environment isn't actually all that compute intensive. intensive. It's I/O intensive. So let's upgrade the I/O, and then you can get away with much smaller servers, which is going to reduce your cost. How do we protect customer confidentiality? This is typically the first question that comes up, and the easiest one to answer. We never have access to a customer's data. So we're not in a position of having to protect anything. What we're doing is extracting AWR data. So it isn't actually any customer data. It's simply performance characteristics. What's the throughput? What's the latency? CPU utilization, things like that. We never see data. There isn't any risk of us not treating the data with the proper confidentiality concerns. We never see it. Second thing is, do we have access behind your firewall? Absolutely not. What we do is we generate a 30-day license for the DPP tool, and we send it to you via email, or we can put it on an FTP site and you can download it that way. And so it's you, the customer, who actually loads it on a laptop. We never log into your system. Now, if you'd like, we're happy to call you on the phone and walk you through the installation process. It's pretty straightforward, but we're there to help if you want. But we never go behind your firewall. We never see your data. And then the last thing is how much time is required. We do an introductory call with one of our Oracle subject matter experts. That's typically a half hour, 45 minutes, figure out what your goals are and if we can help you. And then we send the tool, and it takes 5 or 10 minutes with the software. It literally takes only 5 minutes to run a DPP assessment per server. So if you want to look at the results on 3 different servers, that's 3 times 5 minutes. It's linear. So it's a very, very light lift from that standpoint. The DPP tool automatically generates the report. You're welcome to look at it, report it along, just to validate that there is nothing in it to be concerned about. And then usually on our side, it takes 1 to 2 weeks to come up with a proposal, because we're going to look very carefully at the results, and we're going to play out different scenarios. We're going to figure out what is the best infrastructure solution, and then we want to quantify for you what the cost savings would be. So total, maybe an hour or an hour and 15 minutes, including the introductory call, and then a couple of weeks for us to get back to you with a proposal. So let me turn it over to Mike at this point, because what we want to highlight is, as much as we love our server line and integrity and HPUX, frequently the best answer for a customer situation is an I/O upgrade, storage modernization. So Mike, can I turn it over to you?
Sure thing, Kyle. So yes, thank you. So absolutely, what we're going to do now is just talk a little bit about a couple of use cases. Kyle, if we can move forward a couple to the next one. So we're going to talk about a couple of use cases here where customers were having performance issues, they were having application issues, and they were looking to see how they could turn that around, get some more efficiencies, because these were directly impacting their business. So the first one we're going to take a look at here, Sybil's, credit information bureau, and they basically made their money by running reports, and they were kind of getting to a point where they just couldn't generate enough, and they couldn't meet the demand. So they had a little bit of an aging infrastructure. So what we basically did is we went in and we took a look, and they were expecting that they were going to have to dramatically increase their compute power and spend all of their money and do everything just buying massive amounts of compute power. And they were looking at a lot of different options. And basically what we did is we went in, we took a look, we talked to them, and they decided that it was kind of a combination. It was a kind of combination of compute, but also there was definitely some I/O issues that they were having, some storage concerns. So this is an example where the combination of the HPE, the Integrity blades, they felt that they got the best bang for their buck for the amount of power, the amount of efficiency, but also, again, not having to buy as many cores was saving on their licensing. But as well, with 3-part storage and flash enhanced storage, they didn't have to buy as much compute as they thought, and they still, you can see some of the numbers on the screen, they still had a dramatic improvement, 386% from a processing perspective. And again, they didn't have to buy as many servers as they thought, because when 3-par storage, we added that in, the overall balance of the I/O with the compute was able to save, again, with those the licensing costs and the overall infrastructure. So dramatic decrease in the footprint, and we were able to get them a 50% improvement in their overall production, right, from 10 million to 15 million reports a day, and that just directly correlates to more revenue, right? So better for the business. Next slide, please, Kyle. So this one we're going to talk about. This is another use case example here, and this was pretty much focused on storage. This was for Sony, and they were having some challenges, and they were looking at a lot of different options. They did have, again, a little bit of an older infrastructure with some spinning drives, but they had over 5 racks of competitor storage. And basically what happened was they felt that they were they kept on having some performance issues. They started to realize it was the disk, and they realized that they actually had twice as much storage as they needed, because they kept on having to add disk, and this was an old spinning disk environment. So what we did is we went in, we took a look, and we evaluated with flash, right, with 3-par and an all flash environment. And what we established their I/O performance requirements, and we were able to basically reduce the amount of storage, not just the footprint, but the capacity. We were able to reduce down to the actual capacity needs they needed. We went from 5 racks down to basically it was less than a rack, right? So the storage right here, we went down to 4U, and we were able to get them a 5x performance increase in their application just by going to flash storage, right? So this is definitely an environment where I/O was the absolute bottleneck in the entire environment, right? So again, reduce the amount of actual capacity that they needed, change the architecture, prove that this was the bottleneck in the application, and they couldn't be happier, right? So very, very easy to kind of do that migration over as well. So we'll talk a little bit now about 3-par and how and why it's such a dramatic impact for I/O for Oracle workloads and other multi-tenant workloads, right? So 3-par storage, actually, not a lot of people talk about this, but I think it's very important. 3-par was actually founded back in 2000, I think 1999, 2000, by 3 former Sun server application engineers. So basically what they did is they realized at the time the way most traditional storage architectures are thought of and designed do not work well. They don't work well because they really don't take into consideration a lot of the mixed workloads for the applications. So they designed an architecture that was focused totally around the application point of view. So 3-par is a totally virtualized system, and 3-par has been around. The first product came out in 2003, so it's a mature product set. But we've been virtualized since day one. Basically, what that means is that when you have your workloads, your Oracle workloads or any type of application workloads, it doesn't matter if you have a 500 gig volume or a 5 terabyte volume or 10 terabyte volume. We basically will stripe the data across all the drives, right? So basically what this does is it maximizes and utilizes all the resources of the system all the time. It is also a fully mesh active architecture. So we can go up to 8 controllers or nodes, and it's a full low latency mesh architecture, which again means that any of the nodes, any of the controllers can service any I/O for any data on any disk anywhere in the system. So it is truly a fully cluster, low latency, active mesh cluster with virtualized data across all the drives. So all of the resources of the system can be utilized all the time. So we do not have hot spares sitting around drives doing nothing until something fails, right? It's all distributed. We have something called adaptive sparing. So it's basically just spares disk across all the drives. So again, you're utilizing all of the resources, all of the drives all the time. So this was very important for spinning media, but it's also very important for flash media as well, because in the world of flash now, architecture definitely matters. 3PAR has been a policy-based I/O engine since the very beginning. We've been able to handle any type of media on the back end that's come out for the last 15 years. It doesn't really matter. The architecture is such, because of the wide striping, the utilization, the efficiencies of using all the resources all the time. We were actually one of the best architectures that there is. We consider it is the best architecture for flash, and to be able to handle flash and the changes that flash have brought to the industry, again, to increase those application performance metrics. So we were a multi-tenant workload design, again, since the beginning. So we have a separation of control data and actual data, payload data. We have CPUs, we have ASICs, we have a lot of things that are designed in the system for that multi-workload. But again, now when you talk about applications, modern applications, and especially when you start talking about flash, quality of service, right? So quality of service has been a big factor for a long period of time. But when you're talking about Oracle databases, you have your SAP or an Oracle or all your mission critical applications that are running it. Now all of a sudden the capability to control the actual I/O workloads and manage and ensure that the storage can deliver the resources that are required for particular workloads is very important. And again, some people are saying it might not be as important for flash because the IOs and the throughput are so much higher than spinning disk, but it's actually more important now, right? Because you can have, say, a developer that goes ahead and maybe writes some bad code or does something, and all of a sudden it'll try and take over the entire system. So you have a lot more runway for it to actually take over. So we can do maximums and minimums. So you have that mission critical application. Well, not only am I going to limit maybe to what some of the lower end applications are doing, but I can have a minimum. So I can ensure that application, say this application needs 20,000 IOs minimum. I can assign that floor to it. And if anything ever gets close to getting down to the minimum, we'll just reassign resources to ensure that application, those volumes, get that minimal workload that you need. But the biggest thing in the world of flash is basically latency, right? So latency is where there's the big metric right now, where you try and measure storage with flash, right? So the granularity that we have in 3PAR, we can actually go down to a 0.5 millisecond latency goal per volume. And I know there's some other vendors out there that may or may not have some latency goals, but we are definitely the most granular, down to 0.5 milliseconds. So again, this is a way that we can ensure that application performance and application response time is to what the limits and the requirements that are necessary for those mission critical applications. Next slide, please, Kyle.
Sure thing.
Thank you. And so the other thing that we do as well, we're talking about efficiencies and storage efficiencies. So performance is definitely number one. The latency goals for particular applications is number one. But the key with flash now in the world of flash is that, yes, it's making everything faster. It's providing that opportunity to increase the application performance. But flash is definitely still a costly medium, right? So dollar per gig flash is still much more expensive than spinning media. So what we have to do in the world of flash is then bring in these optimizations, right? These efficiencies. So we have zero detect. Adaptive data reduction is the term that we use for all of our data reduction technologies that we have in 3PAR. So zero detect is, again, a technology that we've had for a long time, basically removing redundant zeros, right? So you don't even have to write those so that's saving IO and overall performance in the system. But as well, on top of that, we have deduplication and compression, right? So deduplication, of course, is removing redundant data. Compression is basically taking data as well as zero detect and other empty space within the particular data, removing that so I basically write less onto the disk. And data packing is what we have after we do all this, and all this is in line, by the way. We basically organize those data because now we're compressing and we're creating a lot smaller I/O. We're organizing them into manageable I/O when we write to the back. So again, we're maximizing the efficiency of the actual I/O writing to disk, right? So the nice thing about 3PAR is that we have all these technologies, all these capabilities to reduce the actual amount of capacity that's required, right? Increasing the usable, right? The metric now is the usable capacity per those particular drives. But we have the flexibility to actually turn on or off any of these technologies. So in the world of Oracle, what we've definitely seen and found is that Oracle databases typically do not deduplicate well, right? A lot of metadata, things like that, just prevent the deduplication from working efficiently. So maybe compression is the main factor. And we've seen already out there that just with the compression alone, not including some of the other factors we have, the other thin provisioning, tier detect, things like that, we're seeing about 2.4 on average, 2.4 to 1 overall compression, which is pretty good. But we gave it the capability to basically turn the dedupe or compression or thin provisioning on or off for particular volumes. So you could have some of your application volumes that are just compressed, some of your application volumes that might be deduped and compressed, some might just be deduped, some might be thick. So nobody else gives you the total flexibility to get granular and control over your applications and manage that efficiency on the back end. Okay? And again, all this is in line with Flash. So from a performance perspective, we're really not introducing a whole lot of performance penalty for any of these at all, right? But again, just giving you the amount of efficiency that you can and control over your applications. I don't have a slide on it. The I/O is important. Making sure those applications are, again, the latency is as minimal as possible. Making sure that, you know, the storage is not the bottleneck. Right, we do very, very well with that. But there's also some data protection mechanisms and things as well that we had that we can talk about. You know, or we could, if you have any interest, we can talk. You know, in other sessions about disaster recovery, where we have application consistent snapshot capabilities for Oracle and a whole lot of other options that we can work in for the disaster recovery as well. But again, these are just some examples of why 3PAR is helping to minimize those I/O bottlenecks and again be able to reduce the amount of CPU and compute that people are buying and overall reducing Oracle licenses.
So I've seen this over and over again where a customer is trying to make the decision about what to do. And do they upgrade to the latest Titanium and stick with HPUX? Do they migrate to Xeon x86 and Linux? We'll do a DPP assessment, and frequently we'll say your servers are fine. It's your I/O that is causing problems. So it's never one solution for every customer. It's really critical to do this assessment. So the things I want to summarize on DPP, first thing is it is no charge. If you have 24 Oracle cores in a production environment, we'd be happy to do this assessment for you. The entire test, once you download the software, load it, and then run the report, significantly less than an hour of your time. So it's not like you have to block off a week to work on this. And then we're going to figure out how to best improve your environment with the least cost possible and the least disruption to your environment, but also give you the biggest ROI. And that's what we document. What's the total cost of ownership for a hardware refresh? And then what's the ROI going to be, both from hardware systems, but also from Oracle license costs? So this is what the whole process looks like. We'll set up that original call. We'll discuss your goals and objectives. We'll then collect the data, which involves just us sending the tool to you. You run it on your system, send us a report back. We analyze the data. We might have some qualifying questions that need to be clarified. Then we design a solution, and then we present that to you with an overview about what the benefit would be, not only from a performance standpoint, but from a cost standpoint. So as we close out, I want to make sure everybody's aware there's tons of additional information, white papers, YouTube videos. You can subscribe to our YouTube channel. And additionally, you can connect to the HPUX customer contact team at the address that you see on your screen there. And coming up next is going to be an update on Integrity Servers, HPUX 2017 release. So stay tuned for the next webinar. It's going to be on May 18th, and there's a ton that we're going to be able to share with you. And for anything that you want to know about HPUX, all you have to do is click on that URL right there, and it'll take you to a great site with tons of data. And that's all for me.